It's no longer really an opportunity or choice, it's an imperative. To telling the story, how do we make sure that we're taking full advantage of any and all assets that are on the grid and at customer premises.
Welcome everybody to the EI360 podcast. My name is Sandy Coughlin. I'm joined here with David Swain, CEO of enx ei360. And David, we welcome October and we welcome our new theme. So this month we're talking acronyms, VPP, DERM. So VPP being virtual power plant, DERM being distributed energy resource management. These are, I guess they're swimming out in the universe right now. They're taking hold, they're gaining great awareness. These concepts they're not new, but they're definitely gaining a lot of ground. And we have a really wonderful guest today who represents the technology that allows for massive data ingest, and it also enables complex queries at a faster speed and greater scale. And David, I would love for you to share with our audience your perspective on VPPs and DERMs, and then obviously this amazing technology, and introduce our guest. So I'm going to turn the time over to you.
Sandy. Well, again, Sandy, thank you. And Mike, great to see you today. And thanks for being with us. And, Sandy, you just described, it's really been fun and exciting to have these discussions about this energy transformation that we're in. One of the things, Mike, that, we've been talking a lot about is just the idea of digitalization and decentralization and decarbonization and, all the various D's that are happening in the industry today. And I think everyone's trying to kind of get their arms around this new world of energy that we find ourselves in. And these podcasts that we're doing in large part are to bring on experts like you that can continue to help our audience really understand and define some of these, not just terms, but really more importantly, what is underpinning them. I mean, I think that our desire and hope is that as we, bring on guests like yourself, that it allows our audience to really begin to understand more about what we mean by DERMs and VPPs, and really what does it require. Mike, one of the things that being in the industry for 30 plus years that I've come to appreciate is it is the largest and probably the most complex machine man's ever built. And so, as we move into this new era, we're really talking about solving some really significant problems that are facing us, challenges, but they're equally opportunities. And we're going to let you speak to that in just a moment. But Sandy asked the question about the, defining DERMs and defining VPPs. And I would tell you, I think that's still very fluid. Everyone seems to have their own little twist on that. Probably no different, Mike, than in your space where, we use terms like AI and machine learning and algorithms, and everybody's using these terms pretty freely. And we're seeing a convergence of a lot of these terms. But just for our audience purpose, one of the reasons we wanted to speak about, kind of DERMs and VPPs as we came out of talking about digital twins is because we really wanted to make the connection to how important not just a digital twin is to this capability, but how important graph technology is to those capabilities. Mike, you and I talk about it frequently about just how NX is different, unique. Our patent is based on that ability to do things with data that we believe no one else can do. But that variation, when you think about a DERM, as Sandy described, that distributed energy resource manager, really being about how more specifically do you manage distributed energy resources. That's really been the focal point. A lot of that's been at the focal point of the utility. But we're also now really hearing a lot about virtual power plants as we begin to think not just about integrating, aggregating, interconnecting new energy resources, but I believe it expands beyond even distributed energy. It expands to talking about how we integrate EV charging. It expands to how we begin to look at smart buildings, grid interactive buildings. It expands to how we begin to look at just the granularity of assets. And I say that because I think, again, it speaks, Mike, to our discussion today is just how important data is and how important it's to break down the silos, how important it is to create the speed of data, how important it is to, put the right data in front of the right people for the right decisions. So, Mike, with that said, I have a few questions for you today. Thank you for being here. And Neo4j, which Mike works for, has been a tremendous partner for enx, and we appreciate that partnership. But I think it would be really good for our audience to hear, Mike, you to share with them just how important data is in the world of digitalization more broadly, how it is solving real world problems, what I would call wicked problems, and help us really begin to get a sense of just how that plays into how we can use that to solve some of these new challenges like DERMs and VPPs. So I'm going to turn it over to you, Mike.
Well, it's a pleasure to be with you this morning, David and Sandy. And yeah, it's quite an interesting situation that we have with the big data challenges that are unfolding right in front of us today. And when you talk about the challenges that the DERMs and the VPPs play, that face today, we have to consider the fact that the technology that got us to where we are today isn't going to get us to where we need to be in the future. And so that's where Neo4j comes in and solving these very challenging problems that you talk about. Just to kind of take a step back, when you think about the traditional technologies that are out there, like relational databases and things like that, they were developed 40 years ago. And they weren't designed for the big data problems that we face today. And so you have to be thinking differently, because the way that we used to operate, running reports and analytics and seeing what happened yesterday and what's happening today, isn't enough. We have to be predictive, right? We're organizations today are leveraging data to be predictive. They're running machine learning models, and they're leveraging the AI to be able to understand what's going to happen next. What are the possibilities that could happen? And when you think about a DERM or a VPP, data is probably, next to the energy that they're managing itself, probably one of the most important assets that they have, that allow them to be able to not only function but to succeed in the marketplace. So you talk about some of those real world problems, and we can look to just the devastating tragedy that happened in Maui recently with the fires, and while the jury's still out with regard to what caused that, we have seen a pattern over time that power lines and down power lines can sometimes be a major challenge, for starting fires, and in situations where you have high winds, or you want to be able to tap into some of the sensors that are out there telling me that there's galloping on the lines, there's tension on the guy wires, and I see that the weather stations are showing a very high wind warning. These are all indicators that something could be happening, and you need to be able to leverage that information, that data in real time, to be able to start making actions taking actions to prevent a tragedy. And it doesn't stop there. It's not enough to say, okay, now I'm going to use my public safety power management capabilities to maybe de-energize part of the grid. But now that creates a whole new set of problems, and that is, who am I affecting? Where can how do I transfer that workload, or that energy to other, in other pathways through other substations and so forth. So it's a problem that you need to have your fingertips on the pulse of every piece of your business to be able to not only react but to act.
Yeah.
And that's really what the NX platform allows you to do. And at the core of that is the engine, and that's Neo4j and that nodal architecture that allows us to, instead of storing data in tables with rows and columns, we organize that data into a digital representation of the physical world. So I can see that I've got a power generation facility, and that's a node in your nodal architecture, and all the data that's associated with it, and all the substations that are supported by that, and the information. And I've computed the distance between them and all the sensors and everything there. So the entire grid, from generation to transmission to the actual distribution and consumption at the meter, is all mapped, and now I can orchestrate. And that's the real key thing is we're leveraging data to orchestrate, how we manage power across the grid. And that's where the DERMs need to be able to be that orchestrator, that's able to move that data. So, I mean, in short, that's I think where this is going.
Mike, you thank you so much, because what you just articulated, there was so much to unpack there. So a few things, I love it. And as a matter of fact, I think we could go on and on about unpacking. But a few things you did say that I want to just pull on the thread a little bit. Talking about that digital representation, and you commented so that you can see, those representation, or that representation of that physical asset. When I hear that, I'm reminded that, when I was managing a utility, just thousands and thousands of miles of geographic territory covered by these assets. Mm-hmm. And I think sometimes we hear things like virtual representation or digital representation, and we talk about being able to actually provide that 360-degree view. We talk about the single pane of glass. I'm not sure we all really truly appreciate. I know I do, because I've had the opportunity to work now with this graph technology and really just understand the depth and the breadth of what this can mean to a DERM and a VPP. But pull on that a little bit, Mike, in terms of two things. One, just how important it is to be able to see yourself, because I think that's such an important statement in the digital representation. And then I think that the last thing you spoke about was the orchestration, and I really believe those are two distinctive comments you made that would be, if you could elaborate just a little more on those.
Yeah, so I think, we talk about this digital representation of the physical, and for a long time that's always been the shiny object that everyone's tried to aspire to get to, but it's always seemed to be just a little bit beyond our grasp. And the reality is that it's here today, and it's we're in a world where technology is changing so rapidly that it sometimes is hard to keep up with it. But we're at a point where we can start, really leveraging that to take advantage of some of the challenges that we couldn't tackle in the past. And yeah, so when we talk about orchestration, we have a myriad of sensors. We have a myriad of customers. All have different requirements, and they have different needs. And so having the visibility to be able to say, I have a virtual power plant here. They've got maybe solar sitting on top of their carports or on top of their building. They're generating their power, and I may have a hospital that has a generator, and they're generating power, or it might be sitting idle. If I'm the DERM, and I'm managing that power, and I want to be able to say, okay, we're facing some brownouts, or we might have an energy emergency. I want to be able to know and have an inventory of where I have potential power, and be able to call up that hospital and say, you know what, could you spin up that generator and I'll buy back that energy. Let's energize the grid. Mr. Business with your solar, array. If we could get some of that energy to fall back into the grid, if we can just start understanding first where are all the potential sources of energy, and to be able to call that up and to be able to leverage that across the grid, at a moment's notice, right? Because it's always peaks and valleys, right? You get scenarios, and then the other is to be able to modulate that energy, correct? So we may have organizations or enterprises that need to power up equipment, and that may they may have to power down some other equipment, maybe take their HVAC down, and then balance their workload. So again, it's a lot of times in the past we would build to peak, and so today it's about managing kind of a baseline so that you can effectively have a continuous level of balanced power across the grid, where you might modulate some down when some needs to come up, and having that ability to orchestrate that and have the visibility to do that is going to be critical.
Mike, that's great. And I would like, if you would be willing to, Mike, this month, maybe at our last session, to have you come back, because I think there's a critical element you're speaking to here. And we're going to talk in the next few weeks about what we call grid interactive efficient buildings, where we literally connect, the C&I loads, the commercial industrial loads, to this virtual power plant idea where, consumers become prosumers. But a key aspect of that, Mike, I believe, is this federation and fabric of graphs.
Yes.
And how important that will be. And just to kind of give a teaser to our audience for that session that we bring you back on, I think that one of the things we're very proud of in both our patent and just our capability is to be able to provide to the utility not just visibility to these assets, but the ability to integrate any and all assets into the grid for the purposes of optimizing those assets, empowering the consumer, creating this true virtual power plant. We believe, and I'll say, Mike, it's a bold statement, we believe we're the only ones that can do a true virtual power plant where we can look at the entire distribution utility, who now is going to find themselves as a distribution system operator, going to find themselves as a distribution market operator, where we're now not looking at, just integrated resources so we can plan for more generation and transmission and substations from a centralized to loads, but to be looking at integrated distributed resource planning, which is what our system does, where we're really beginning to look at the decentralization of all these assets, to begin to look at all this IoT, all this intelligence. We believe that, as you described earlier, Mike, and thank you for saying this, we are here. The technology is here. The domain knowledge is here. We are in the time today where we can really, truly begin to use assets from a production standpoint, from a load modulation standpoint, to create results, solutions that we've never seen before. So that whole federation and fabric of graph technology, Mike, I believe is an imperative that I'd love to have you come back and speak to. But we'll make that another session. And Mike, I tell you, I think our audience, I know, has gained a lot from what you shared today. Any last thoughts before we wrap this up today, Mike?
Well, I was just going to comment on, and I think you touched on it, I think the holy grail is really getting beyond the meter, right? Behind the meter. Yep. And that's for a number of reasons. One, it's, the DERM is able to better, kind of coach, their customers on how to use energy more wisely. But also the energy consumer has more visibility so that they can use energy more wisely. I mean, it used to be you had, your air conditioning, your refrigeration and lights, right? And some TVs, but, if you're a consumer, but now we've got EV charging. Businesses have a lot more smart devices, and we need to, leverage these smart devices to in essence, bring those smarts, not just from, the generation to the meter, but beyond the meter. And I think, again, that's one of the areas where, your platform is able to, again, help orchestrate those electrons, right? And again, it comes down to the data and being able to harness that data so that you can effectively handle that workload.
Now, Mike, I got to tell you, I'm a little disappointed. You keep talking beyond the meter, but you haven't mentioned generation to toaster. And,
generation to toaster.
That's kind of our saying, right? But I appreciate your emphasis on that. And one of the things too, Mike, when we get a chance to visit again, we've been talking to a number of municipals about what this means in the in the context of smart cities. We've seen a lot of failures with smart cities. And you touched on a moment ago, there's a lot of Internet of Things and intelligence that's being deployed in communities and at the consumer level. And we need to be able to tap into that intelligence and truly make a smart city a smart city. We're in that area where we're beyond smart or shiny objects. Now we're talking about how do we use data. Mm-hmm. So Mike, thank you so much. And Sandy, we'll turn it back to you.
Well, that was awesome. Thank you, Mike. Appreciate it. David, I will echo we are here, and we are grateful that Mike is here with us and Neil for today. So grateful for that relationship. Thank you so much for joining us today, Mike, and we will see you next time.
My pleasure.